Here's a solution for day one, problem one. Simplify as much as possible. We have the cube root of 16x to the fifth power. 16 is not a perfect cube number, but 16 can be factored using a perfect cube. So let's rewrite this expression and factor the 16 as 8 times 2. The reason for doing that is that 8 is a perfect cube. It's a number that you can take the cube root of and get a whole number result. Now, x to the fifth power itself is not a perfect cube, but we can factor x to the fifth power so that we do have a perfect cube in x. It would look like this. X to the fifth can be replaced with x to the third power times x to the second power. Recall that adding exponents together when multiplying variables is how you could have created an answer such as x to the fifth power to begin with. X to the third power is a perfect cube, meaning you can take the cube root of it and get a nice result. So now that we've rewritten the expression like this, we can take the cube root. The cube root of 8 is 2 because 2 cubed is 8. 2 times 2 times 2 is 8. The cube root of x cubed is x because x times x times x is x cubed. Now, two of the factors within the grouping symbol we're not able to take the cube root of, and so we're going to leave them in that same radical symbol. So inside of the cube root symbol, there's still going to be a 2, and there's still going to be the x squared. And so this is as far as we're able to simplify the original expression. This is equivalent to the original expression, but we were able to rewrite what was inside the radical symbol so that we were able to take the cube root of at least some of the pieces in there. Now, day one, problem 2. Factor this polynomial. This is a polynomial in x. Its highest exponent is 3, so it's a third degree polynomial. It has 2 terms that are separated by the subtraction symbol. The coefficient of the first term is 2. The coefficient of the second term is the -6. Both terms have x in them. When we factor this, this means to rewrite this subtraction problem as a product. Let's look for a greatest common factor. The greatest number that divides into this coefficient and into this coefficient is 2, because 2 divides into 2 evenly, and 2 divides into 6 evenly. Now let's look at the variables. The greatest amount of x's that divides into this and into this is a single x. Because this last term only has a single x, we can't divide more x's into this than what's there to begin with. After the 2x, we're going to put a parenthesis and write down what the other factor would be. 2x times what creates 2x cubed. What we're lacking is an x squared. 2x times x squared is the 2x cubed term. Again, the idea here is adding the exponents together. If this x has a 1, when you add those exponents, that's how you'd have x cubed. Then a minus sign to fit this, and let's figure out the next term in here. 2x times what makes 6x? How about a 3? 2x times 3 is 6x. Close up the parenthesis, and we have factored this binomial. It's kind of like doing the distributive property in reverse. 2x times x squared is the 2x cubed term, and 2x times the -3 is the -6x term. This is now a product. There's multiplication right here, and that's what factoring is, writing an expression as a product of terms.